Hello and welcome back to Instructor Alison online tutorials. In this video, we're going to solve problem on differentiation under calculus. So here is a problem: if y is equal to x squared, find dy over x using first principle. Ordinarily, we can use the direct formula of differentiation dy over the x equal to nx raised to the power of n minus 1 to solve this problem, where n represents the power we are having here. So if you can substitute n for the power, we have 2x raised to the power of 2 minus 1, and this will give us 2x. So 2x would have been the answer if we had used direct formula. But then we can still get the same answer using first principle. So that is what we are asked to do. So please make sure you subscribe to my channel, and thank you very much for following me up and liking my videos. I love you so much. Please make sure you like the video and also subscribe to my channel. All right, so for using first principle to solving this problem, the first thing we're going to do is to quote the expression for first principle. You know, it started by saying dy will be equal to, we have it in two phases. When you start by saying y plus the change in y equal to x plus the change in x, or you can add a function to it as the case may be. So you can see that dy will be equal to the what we have as function of x plus the x minus y, which is the same thing as saying dy over the x, dy will equal to function of x plus the x minus function of x, if y is equal to function of x. All right, this is the model we're going to use in solving the problem. So let's start making substitution. So at this point, we are looking for dy over the x of this function. We want to differentiate this function using first principle. So we're going to do this. Anywhere we see x, we substitute x plus the x. So I will say dy over the x, or dy is equal to function of x plus the x raised to the power of 2 minus what is function of x is y, like what we stated there. Y is equal to function of x, which is equal to x squared. So we have x squared here. By using Pascal triangle to expand this function, we have 1, 1, 1, 1, 2, 1. So this is expansion for square. So let's use it to expand this problem. The y will be equal to, here we'll be having 1 times x will give us x squared plus 2 times x dx will give us 2x dx. 1 times the x will give us plus the x squared. So that is the expansion. Hence, we don't have a function, let's say 5 or 7 or any of the constant there. We can do away with this bracket so that we can have enough space to do our job, minus x squared. So at this point, you can see that this is common and this can easily cancel out. So dy will be equal to 2x dx plus dx squared. At this point, we are going to divide both sides by x, by the x. And we divide both sides by the x, divide both sides by the x. You can see that this will cancel this particular one, and this will reduce one of this. So dy over dx equal to 2x plus dx. At this point, we are still saying that the x is surfacing even when we have divided both sides by the x. So we are kind of saying dy over the x now is going to be equal to the limit of 2x plus dx as x, or dx as the x tends to 0. So whenever we see the x, we substitute 0. So at this point, we have dy over the x equal to, we have 2x plus 0, which is equal to 2x. It gives us that answer. Thank you very much for enjoying Instructor Alison online tutorial, and please stay subscribed if you've subscribed already. Like the video, drop a comment, and subscribe to my channel. Thank you very much, and stay tuned.